Imagine for a moment an idea so profoundly unsettling it seems to tug at the very threads of what you call real. Picture an astronaut utterly alone, plunging headlong into the maw of a colossal black hole. What does she experience as she crosses that infamous boundary, that point of no return we call the event horizon? Well, according to Albert Einstein's magnificent general theory of relativity, our intrepid explorer would feel absolutely nothing. No jolt, no cosmic rip, no sudden abyss. She would simply continue falling, weightless, completely unaware that she has just sealed her fate. She wouldn't even perceive the moment she passed beyond the universe's most unforgiving threshold. She would, of course, sense the relentless tidal forces accelerating her towards the singularity at the heart of the beast, but the journey across the boundary itself would be entirely benign, a tranquil passage into an unknown eternity. Yet, this tranquil descent is only one side of an impossible coin. Now, imagine yourself, far, far away, perceiving this exact same astronaut through the most powerful telescopic instrument imaginable. What would you witness? Here, the very laws of physics seem to contort reality into a nightmare. As your senses track her closer and closer to that horizon, she would appear to slow down, to stretch, her image growing dimmer and redder, until she seemed to freeze, eternally suspended just at the boundary. She would never in your observable reality actually cross that line. But there is a further, far more chilling prediction, one that stems from the delicate and often violent marriage of gravity and quantum mechanics. Approaching that horizon, the astronaut would collide with something utterly cataclysmic, a firewall, a searing, infinitely hot wall of high-energy particles born of quantum fluctuations that would instantly incinerate her, leaving no trace. Think about that for a moment. Just let that sink in. Two entirely distinct, fundamentally contradictory realities, both derived from our best understanding of the universe. From the astronaut's perspective, an undisturbed passage into the unknown. From your distant vantage point, an instantaneous, fiery annihilation. So, can a person be simultaneously alive and dead, inside the black hole and outside it? How can both possibly be true? Leonard Susskind, one of the brilliant minds grappling with these cosmic conundrums, asserts that, as unsettling as it sounds, both stories are equally valid. They simply exist in different reference frames, different systems that can never fully communicate with each other. The universe, in its profound complexity, somehow protects itself from this paradox by respecting the inviolability of quantum information, a concept called black hole complementarity. The astronaut cannot escape to tell you she survived, nor can you dive in to confirm her demise, because by the time you reached her, she would have long since ceased to exist, absorbed by the black hole's ultimate singularity. But the sheer fact that such mutually exclusive yet equally valid perspectives can arise from the very laws of physics we cherish, well, it shatters our intuitive grasp of what an objective reality even is. It makes you ask, what if the world itself is not as solid as it seems? What if these glitches in the cosmic code are hints of something deeper? What if we are, in fact, living inside a simulation? This idea, once relegated to the fringes of philosophy and late-night science fiction debates, has now permeated the consciousness of Silicon Valley billionaires and Nobel laureates alike. Could our reality be a grand illusion, a hyper-realistic computer program meticulously crafted by some advanced intelligence? The concept, of course, is far from new. It harks back to Plato's cave and René Descartes' malevolent demon. But it has gained startling traction in the modern era. And why is that? It's because the deeper we probe the universe's fundamental laws, the more strange and code-like its behavior appears to be, particularly at the quantum level. The discretization of energy, the non-locality of entangled particles, and the inherent limits on information transfer all seem strangely reminiscent of a meticulously rendered computational environment, one that seems to be demanding a final resolution to that ultimate conflict between quantum mechanics and general relativity. But let's pull back from the dizzying precipice of the event horizon for a moment and explore other oddities, closer to home, that fuel such radical thoughts. Consider the enigmatic presence of something we call Planet 9. It sounds like the fantastical title of an old science fiction novel, doesn't it? Yet it stands as a very real and very compelling scientific hypothesis. Imagine the farthest, most desolate reaches of our solar system, that icy, sprawling dominion beyond Neptune's distant orbit known as the Kuiper Belt. This is a frigid wilderness, a cosmic Siberia, populated by frozen dwarf planets like Pluto, by scattered asteroids, and the nuclei of countless comets. Yet, out here, something is amiss. Astronomers, meticulously observing the most remote inhabitants of this belt, the so-called trans-Neptunian objects, have noticed a profound, almost inexplicable anomaly. Several of these icy wanderers move in orbits that simply refuse to conform to the standard gravitational tugs and pushes from the 8 known planets. Their paths are not only extraordinarily elongated, stretching vast distances into the void, but they also appear eerily clustered. Their closest points to the Sun, their perihelia, all seem to align, pointing roughly in the same cosmic direction. And their orbital planes, strangely, are tilted to the general plane of our solar system in a remarkably similar fashion. This convergence, this choreographed cosmic dance, is statistically improbable to the extreme. The statistical likelihood of this clustering being a product of sheer random chance is calculated to be only 0.007%. Unless, that is, someone or something of immense unseen influence is hiding out there in the frigid darkness, orchestrating these icy blocks into such a peculiar gravitational ballet. In the year 2016, astronomers Konstantin Batygin and Michael Brown, hailing from the prestigious California Institute of Technology, published their groundbreaking calculations. Their models indicated that the colossal gravitational pull of a hypothetical massive planet dwelling on an incredibly distant orbit could indeed perfectly account for these perplexing anomalies. According to their precise computations, this mysterious Planet 9 would need to be quite substantial, its mass estimated at approximately 5 to 10 times that of our Earth. So we are speaking of either a super-Earth or a mini-Neptune, a world far grander than anything we've found in the outer system besides the gas and ice giants. And its presumed orbit? Well, it's simply gigantic. The distance from our Sun would vary wildly, from around 400 to an astonishing 800 astronomical units. Just to put that into perspective for you, 1 astronomical unit, or AU, represents the average distance from the Earth to the Sun, roughly 150 million kilometers. Neptune, the farthest confirmed planet we know, lies at a mere 30 AU. Can you truly conceive of the unfathomable remoteness of this conjectured 9th planet? At such an extreme distance, it would be incredibly faint, barely catching the Sun's meagre light, making it extraordinarily difficult to spot. And one complete journey around the Sun. According to various estimates, it would take a staggering 10,000 to 20,000 Earth years. Since the very dawn of Sumerian civilization, this phantom world might not have completed even a quarter of its colossal orbital path. The intense search for this elusive ghost planet is now in full swing, employing the most powerful telescopes humanity possesses, yet, so far, without a definitive success. The predicted expanse of the sky where it might hide is enormous, and the object itself is both dim and excruciatingly slow-moving. Of course, alternative explanations abound. Perhaps it is not a single colossal planet, but rather the cumulative gravitational whispers of countless smaller, as yet undetected icy bodies. Or, even more bizarrely, could it be a primordial black hole, no larger than a grapefruit silently lurking in the darkness? That would be something, wouldn't it? But if Planet 9 is eventually found, if its elusive form is at last revealed, it will irrevocably revolutionize our fundamental understanding of the formation, the evolution, and the very boundaries of our solar system. Its discovery would be nothing short of a cosmic revelation. From the chilling, unseen edges of our own planetary home, let us travel back, not just in space, but in time itself, all the way back to the very beginning of everything, to what we call the Big Bang. But first, a crucial clarification is in order. The name itself, Big Bang, is profoundly deceptive. It wasn't an explosion in the sense we typically imagine. like a bomb detonating in an empty void and scattering fragments outwards. No, it's far more profound than that. It is the cornerstone theory about the origin and the subsequent evolution of the universe itself, encompassing space, time, matter, and energy. According to this universally accepted model, approximately 13.8 billion years ago, the entirety of the observable universe, all the matter, all the energy, and indeed space-time itself, was compressed into a point of unimaginable density and temperature. This singular, incomprehensible state is referred to as a singularity. What, if anything, existed before this moment remains the greatest enigma, perhaps a question that classical physics can never truly answer. The fundamental limits of general relativity break down completely at the singularity, forcing us to seek answers in the as yet undiscovered domain of quantum gravity. The pivotal concept here is the expansion of space itself. Picture the surface of an inflating balloon. You've drawn dots upon its surface, and each dot represents a galaxy. As the balloon expands, the distances between these dots steadily increase. The farther apart any two dots are, the faster they appear to recede from one another. But crucially, they are not flying across the surface. It is the rubber itself, the very fabric of the balloon, that is stretching. So too with our universe. Galaxies are not merely hurtling through a pre-existing emptiness. They are moving away from each other along with the expansion of space-time itself. This elegant, profound idea explains the homogeneity we perceive in the cosmos on the larger scales. Immediately after this start, the universe was impossibly hot and dense, a primordial soup of elementary particles, primarily quarks and gluons, existing in a state of plasma. Literally within the first fleeting fractions of a single second, a period of what we call cosmic inflation occurred. This was an ultra-rapid, exponential expansion that smoothed out the nascent universe to an astonishing degree and seeded the tiny quantum fluctuations that would later become the embryonic structures of galaxies. These quantum ripples are absolutely critical. Without them, the universe would have remained perfectly uniform and utterly devoid of structure. In the first few minutes, the universe cooled just enough for quarks to combine, forming protons and neutrons. These in turn began to fuse, forging the nuclei of the lightest elements, predominantly hydrogen and helium. It's a stunning fact that almost all the hydrogen and helium in the entire universe originated from this brief, fiery epoch, a process called Big Bang nucleosynthesis, which accurately predicts the observed elemental abundance we experience today. Then, approximately 380,000 years later, a monumental shift occurred. The universe had cooled sufficiently for free electrons to combine with these newly formed nuclei, creating neutral atoms. Prior to this pivotal moment, the universe was an opaque veil, filled with a hot, ionized plasma that was utterly impenetrable to light. After the formation of neutral atoms, it suddenly became transparent, and the light that was emitted during that epoch, the universe's radiant birth cry, could finally travel freely through the newly transparent cosmos. It is this ancient light, stretched and cooled by billions of years of cosmic expansion, that we observe today as the cosmic microwave background radiation, or CMB. Its accidental discovery in 1965 by Arno Penzias and Robert Wilson was one of the most significant finds in scientific history. This faint uniform glow comes from all directions in the sky, its waves having stretched over eons, its temperature dropping to a mere 2.7 Kelvin, just slightly above absolute zero. Satellites like COBE, WMAP and Planck have created incredibly detailed maps of this radiation, revealing minuscule temperature fluctuations, the very ripples left over from the quantum uncertainties of the early universe. This is quite literally a photograph of the infant universe, showing us where matter was ever so slightly denser, the gravitational seeds from which galaxies would later grow. Another powerful confirmation of the Big Bang model emerged from the pioneering observations of Edwin Hubble in the 1920s. He definitively discovered that galaxies are not static, they are actively moving away from us. Even more remarkably, he found that the farther a galaxy is, the faster it recedes, a relationship now known as Hubble's law. This phenomenon, observed as a redshift in the light from distant galaxies, is a direct, undeniable consequence of the expansion of space itself. Of course, the Big Bang Theory, for all its explanatory power, does not provide all the answers. But isn't that the beauty of science? What truly existed before the singularity? What is the mysterious dark matter constituting about 27% of the universe, detectable only through its gravitational influence? And what is the even more enigmatic dark energy, making up approximately 68% and responsible for the accelerated expansion we observe today? Ordinary matter, the stuff we're made of, accounts for a mere 5% of the cosmos. Yet, despite these remaining profound mysteries, the Big Bang stands as the undisputed cornerstone of modern cosmology, confirmed by an overwhelming multitude of observational data. Since we are pondering strange signals and unseen influences from the depths of space, let's turn our attention to one particular star that caused a genuine sensation just a few years ago. Tabby's star, officially designated KRC 462852. It lies in the constellation Cygnus, a remarkable 1,470 light-years from us. The star itself is quite unremarkable, perhaps a touch larger and hotter than our Sun, but otherwise ordinary. Yet, in 2015, a team led by astronomer Tabitha Boyajian, painstakingly sifting through data from the Kepler Space Telescope, a mission designed to detect planets by observing minuscule periodic dips in starlight, stumbled upon something utterly wild about KIK 462852. Its brightness did not dip regularly and subtly, as a planetary transit would cause. Instead, its light dimmed irregularly, chaotically, and by an astonishingly large amount, up to 22%. Normal planets, by contrast, induce predictable dips of mere fractions of a percent. Something enormous, or a colossal swarm of somethings, was periodically blocking a significant portion of the star's light. Hypotheses immediately rained down upon the scientific community. Was it a vast swarm of comets, perhaps recently disturbed by a passing star? Could it be a giant cloud of interstellar dust, or perhaps even debris from a planetary collision? And then, astronomer Jason Wright cautiously, almost speculatively, suggested the most intriguing possibility of all. What if these were signs of an alien megastructure? Could it be, for instance, a Dyson sphere or its fragments, gigantic constructions conceived and built by a super civilization to harness the vast energy output of their star? This idea, as you might imagine, exploded across the internet, and Tabby's star quickly earned the moniker the Alien Megastructure Star. Scientists naturally approached this sensational claim with rigorous skepticism, immediately initiating intensive investigations. Searches for artificial radio signals, a key objective of the SETI, Search for Extraterrestrial Intelligence project, yielded nothing. Similarly, searches for excess infrared radiation, which any heated megastructure would inevitably emit, also proved unsuccessful. The crucial observation that ultimately shifted the consensus came from detailed analysis of the dimming itself. The star dimmed more significantly in blue light wavelengths than in red light. This differential dimming is a characteristic signature of fine dust, which scatters blue light far more effectively than red light. Solid objects, such as planets, or indeed hypothetical artificial structures, would dim the star's light relatively equally across all wavelengths. Thus, the thrilling alien megastructure hypothesis was, to a large extent, reluctantly dismissed. Currently, the most widely accepted explanation points to a truly enormous cloud of dust, perhaps originating from a recent catastrophic destruction of comets or the collision of large asteroids. But here's the kicker. Even this currently favoured hypothesis cannot fully account for all the perplexing oddities observed, especially the extreme depth and the unique shapes of some of the light dips. Tabby's star, therefore, continues to be a profound mystery, a shining example of how science confronts and grapples with anomalies, pushing the boundaries of our understanding. While we ponder the distant possibility of someone out there constructing colossal megastructures, humanity itself has already embarked on sending its own eloquent, if infinitesimally small, messages into the vastness of interstellar space. The first such letters in a bottle were the Pioneer plaques. In the years 1972 and 1973, the Pioneer 10 and Pioneer 11 spacecraft were launched. These pioneering probes were the very first man-made objects to attain a velocity sufficient to definitively escape the Sun's gravitational embrace and begin an endless journey into interstellar space. At the visionary initiative of journalist Eric Burgess, and under the expert guidance of the celebrated astrophysicist Carl Sagan and Frank Drake of the renowned Drake equation fame, a unique message-bearing plaque was meticulously crafted. This plaque is a gold anodized aluminum plate measuring 15 by 23 centimeters, robustly affixed to the antenna support strut of each spacecraft. Engraved upon its metallic surface is a carefully considered array of information, designed with the profound hope that it could one day be deciphered and understood by any extraterrestrial intelligence that might intercept it. In the upper left corner, a diagram illustrates the hyperfine transition of the hydrogen atom. This is a fundamental universal process with an exquisitely known frequency of 1,420 MHz and a corresponding wavelength of 21 centimeters. These precise values were ingeniously employed as universal units of measurement for all the subsequent information on the plaque, a stroke of scientific genius providing a cosmic Rosetta Stone. At the very center of the plaque are silhouette images of a naked man and woman, positioned against the outline of the Pioneer spacecraft itself, providing a sense of scale. The depiction of nudity, incidentally, sparked considerable controversy at the time, but Sagan staunchly insisted on its inclusion for clarity and universality. Nearby, the average height of the woman is meticulously indicated in those crucial hydrogen units. To the left, a detailed pulsar map radiates outward from the position of our Sun. This map denotes the directions to 14 known pulsars, highly magnetized, rapidly rotating neutron stars, and their remarkably stable pulsation periods, again, all expressed in hydrogen units. Pulsars are, in essence, cosmic beacons with extraordinarily stable periodic signals, which nonetheless slow down ever so slightly over eons. By knowing these periods, and comparing the rates encoded on the plaque with their own current observations, a hypothetical alien civilization could not only pinpoint our exact location within the swirling Milky Way galaxy, but also precisely deduce the time the spacecraft was launched. At the bottom of the plaque, a diagram of our solar system is depicted, with an arrow unmistakably pointing to Earth and a curved line tracing the trajectory of the Pioneer spacecraft's journey. The chances of these tiny, precious plaques ever being found in the immeasurable vastness of space are infinitesimally small. Space truly is colossal beyond human comprehension. Yet their creation and launch represented an incredibly important symbolic gesture, a profound message in a bottle cast into the endless cosmic ocean. The Pioneer spacecraft silently carrying these golden greetings are now flying far beyond the orbit of Pluto, continuing their boundless, solitary journey through the interstellar void. From these messages flying outward, let us now return to the oddities residing within the very confines of our solar system. Take Uranus, the seventh planet from the Sun, an ice giant of majestic proportions. Its most striking peculiarity, its defining quirk, is its astonishing axial tilt. It rotates on its axis, lying almost entirely on its side. While most planets rotate almost vertically relative to the plane of their orbit, Earth, for instance, is tilted by a modest 23.5 degrees. Uranus is tilted by a colossal 98 degrees. It quite literally rolls along its orbit, like a bowling ball on a cosmic lane. How then did this extraordinary orientation come to be? The most widely accepted theory posits a giant collision that occurred early in the tumultuous history of the solar system. The young, still-forming Uranus, it is believed, suffered a catastrophic impact with a protoplanet, an embryonic world perhaps the size of Earth. This cataclysmic impact, far from being a glancing blow, violently knocked it over, irrevocably altering its rotational axis. This extreme tilt has utterly wild consequences for the ice giant. Uranus takes a ponderous 84 Earth years to complete one orbit around the Sun, and because of its radical tilt, one of its poles is continuously bathed in sunlight for an astonishing 42 Earth years, experiencing an endless polar day, while the opposite pole is simultaneously plunged into 42 years of unrelenting darkness, an interminable polar night. Imagine a single winter or summer season lasting for half a human lifetime. For an extended period, Uranus appeared to astronomers as a rather monotonous, featureless blue-green ball, its characteristic colour derived from the methane in its atmosphere. However, the Voyager 2 spacecraft, during its historic flyby in 1986, and later the Hubble Space Telescope, unveiled a more dynamic, turbulent reality beneath that serene exterior. They revealed intricate cloud formations, hurricane-force winds screaming across its atmosphere at speeds up to 900 km per hour, and even colossal dark storms. How the weather patterns develop and evolve with such extreme half-lifetime seasons remains a profound mystery. Adding to the enigma, the temperature across the entire planet is surprisingly uniform, despite one pole being heated by the sun for 4 decades straight. And Uranus's magnetic field is something else entirely. It is bizarrely tilted by 60 degrees relative to the planet's axis of rotation, and its magnetic center is significantly offset from the planet's geometric center. It is thought to be generated not deep within its core, as on Earth, but rather in a conducting layer within its vast, icy mantle. Because of this sideways rotation and the highly skewed magnetic field, Uranus's magnetosphere, the region of space dominated by its magnetic field, constantly tumbles and twists, creating an extraordinarily complex and dynamic environment. Uranus stands as one of the most mysterious and, regrettably, least studied planets in our solar system, eagerly awaiting new missions to unlock its many secrets. Speaking of objects on unusual trajectories, one cannot possibly forget a rather recent, utterly bizarre performance that captured the world's imagination. On the 6th of February, 2018, Elon Musk and his audacious company, SpaceX, launched their super heavy Falcon Heavy rocket, one of the most powerful boosters ever built. And as a test payload, instead of a mundane utilitarian concrete block, they sent Musk's very own cherry-red Tesla Roadster into the unforgiving vacuum of space. Behind the wheel, a mannequin dressed in a sleek SpaceX spacesuit sat in silent vigil, whimsically named Starman, a clear, affectionate nod to the legendary David Bowie. On the dashboard, an inscription, both playful and philosophical, read, "Don't panic," a direct homage to the brilliant Douglas Adams. And as the car drifted away, Bowie's iconic song Space Oddity played, broadcasting an ethereal soundtrack to the void. Why would they do this? Officially, it was a payload test for the maiden flight of the Falcon Heavy, demonstrating its formidable lift capabilities. Unofficially, it was a stroke of brilliant public relations, a daring, extravagant, and utterly unforgettable statement, and quite simply because Musk, with his boundless ambition, could. The rocket successfully placed the Roadster into an elliptical orbit around the Sun, an immense path that extends beyond the orbit of Mars and then swings back towards Earth's orbit. One complete revolution around the Sun takes approximately 557 days. The car is still flying out there, a silent sentinel, officially the fastest sports car relative to the Sun. What will be its ultimate fate? Predictions suggest it could continue its solitary orbit for millions of years, but likely not forever. The relentless onslaught of cosmic radiation and tiny high-velocity micrometeoroids will gradually, inexorably, destroy its paint, its plastic components, its rubber tires, eventually leaving only its skeletal metal frame. Furthermore, the subtle, long-term gravitational nudges from planets will inevitably alter its orbit, and there is a tiny, yet non-zero chance that in millions of years it could, by sheer cosmic coincidence, collide with Earth or Venus. For now, Starman silently keeps watch in his red convertible, an improbable, iconic, and most unusual artificial satellite of the Sun. The Roadster, for all its charm, is more of an art object, a flamboyant gesture. But the Voyager Golden Records represent a truly serious, profoundly ambitious attempt to introduce humanity in all its complexity to the universe. Launched in the pivotal year of 1977, the Voyager 1 and Voyager 2 spacecraft, after completing a grand, unprecedented tour of the giant outer planets, Jupiter, Saturn, Uranus and Neptune, continued their epic journey, heading inexorably into interstellar space. Voyager 1 was the first to majestically cross the heliopause, the boundary where the Sun's influence diminishes, leaving our heliosphere in 2012, with Voyager 2 following suit in 2018. On board each of these twin spacecraft, firmly affixed, is a gold-plated copper phonograph record, an exquisite time capsule painstakingly assembled under the guiding vision of the same Carl Sagan. It is a genuine message to the cosmos, designed to endure for eons. Recorded on it are 115 carefully selected images, encoded in analog format. Scientific diagrams illustrating DNA and human anatomy, evocative images of Earth's diverse nature, scenes from the daily lives of people from a multitude of cultures across our planet, examples of human architecture and technological achievements. Accompanying these visuals are the sounds of Earth: the whisper of the wind, the patter of rain, the rumble of thunder, the crash of ocean waves, the melodic songs of birds, the distinctive sounds of various animals, the simple rhythm of human footsteps, the universal joy of laughter, the poignant cry of a baby, the purposeful sounds of tools, the powerful chugging of trains. There are also short greetings spoken in 55 different human languages, including ancient tongues and even Russian. Здравствуйте, приветствую вас, meaning hello. I greet you. There is even a truly unique recording, the actual brainwaves of Ann Druyan, a key project participant and Carl Sagan's widow, as she meditated on profound concepts of love and the universe. And of course, music, approximately 90 minutes of it spanning an incredibly wide spectrum. From the classical compositions of Bach, Mozart and Beethoven, to the modernist sounds of Stravinsky, the jazz of Louis Armstrong, the rock and roll of Chuck Berry, the soulful blues, and a rich tapestry of ethnic music from around the world: Peru, Bulgaria, Java, India and beyond. On the protective aluminum cover of each record are intricate instructions for playback, along with the same pulsar map found on the Pioneer plaques. These records are engineered to endure for billions of years, a testament to human hope. Will they ever be found? It is highly improbable, but this represents the most detailed, durable and heartfelt message humanity has ever launched towards the stars, a powerful symbol of our insatiable curiosity and our enduring hope for connection. The Voyagers are currently the most distant man-made objects, silently carrying this extraordinary greeting from our home planet into the boundless void. From specific objects, let's delve into the very fabric of reality itself, to theories attempting to describe its deepest nature. I'm talking about string theory. This is one of the most ambitious and prominent directions in theoretical physics, aspiring to the ultimate title of a theory of everything. A single, unifying framework that would elegantly unite all fundamental interactions, critically including gravity, with which quantum mechanics currently has profound unresolved problems. The core revolutionary idea of string theory is that fundamental particles, those tiny constituents like electrons, quarks and photons, are not point-like, indivisible objects as we currently understand them. Instead, they are posited to be infinitesimally small, one-dimensional vibrating strings. Their size is on the unfathomable order of the Planck length, a staggering 10 to the minus 35th power meters, an unimaginably astronomically tiny scale. Different modes of vibration, like different notes played on a cosmic string, manifest themselves as different particles, each endowed with its unique properties such as mass and charge. Picture a guitar string. Different vibrations produce different musical sounds. Here, different vibrations produce different fundamental particles. The primary, most compelling advantage of string theory is its inherent ability to naturally incorporate gravity. One of the specific vibration modes of these fundamental strings corresponds to the graviton, the hypothetical particle that is believed to mediate the gravitational interaction. This offers a powerful, tantalizing hope for finally unifying the two great pillars of modern physics: quantum mechanics, which governs the subatomic realm, and Albert Einstein's general theory of relativity, which describes gravity and the large-scale structure of the cosmos. But there is a significant price to pay for this elegance. For the intricate mathematics of string theory to function correctly, to be consistent, it absolutely requires the existence of additional spatial dimensions beyond our familiar 3 plus the dimension of time. Most popular versions of the theory necessitate 10 or even 11 dimensions of space-time. So, where are these elusive extra dimensions? Theorists propose that these additional dimensions are compactified, or curled up, on incredibly small microscopic scales, so tiny that we simply do not perceive them in our everyday existence. An analogy might help. Imagine a garden hose viewed from a great distance. It appears to be a one-dimensional line, but as you approach it and experience it closely, you realize it also possesses a second circular dimension curled around its length. String theory is an exceptionally complex, mathematically elegant, and profoundly beautiful construct. However, it currently suffers from a crucial absence: direct experimental confirmation. The colossal energies required to probe these incredibly small scales and verify its predictions are far, far beyond the capabilities of any modern particle accelerators. It remains firmly at the forefront of theoretical physics, an area of active, intense research, rigorous mathematical development and passionate debate, pushing the very boundaries of our understanding of reality. While brilliant theorists grapple with vibrating strings and elusive extra dimensions, astronomers at times stumble upon signals that are utterly baffling even without recourse to such advanced theoretical constructs. The most famous such case, shrouded in persistent mystery, is the iconic WOW signal. It happened on a warm August the 15th, 1977. Astronomer Jerry Ehman, meticulously reviewing data printouts from the Big Ear radio telescope at Ohio State University, made an astonishing discovery. On one of the printouts, he perceived an extremely strong, unequivocally narrow-band radio signal that lasted for precisely 72 seconds. It originated from a specific region of the sky within the constellation Sagittarius. The signal was so profoundly unusual and so remarkably powerful, a staggering 30 times stronger than the typical background noise, that Ehman, in a moment of sheer scientific exhilaration, circled it with a red pen and scrawled that single evocative word in the margin of the printout. Wow! What then made this signal so exceptionally special? Firstly, its narrow frequency band. Natural sources of radio emission in the cosmos usually make noise across a broad spectrum of frequencies, like a waterfall of sound. But this signal was concentrated into an incredibly tight, narrow frequency band, a characteristic far more indicative of an artificial engineered transmission. Secondly, and perhaps even more tantalizingly, the frequency itself, 1420 MHz. This is the celebrated hydrogen line, the precise frequency of radiation emitted by neutral hydrogen atoms, the most abundant element in the entire universe. Many scientists, including SETI pioneers Giuseppe Cocconi and Philip Morrison, had long postulated that this specific frequency would be a supremely logical, universally recognizable choice for interstellar communication, a kind of cosmic meeting frequency for any advanced civilization. And then, here comes a signal, strong, narrow band arriving precisely at this frequency. Intriguing, isn't it? But the core, enduring mystery of the WOW signal is that it has never ever been repeated. Astronomers have repeatedly aimed powerful telescopes at the exact same region of the sky, meticulously searching, but all in vain. Silence. The utter lack of repetition leaves a multitude of unanswered questions. Was it simply terrestrial radio interference, perhaps reflected off some object in space? Unlikely. Its unique characteristics do not quite fit that explanation. Was it an unknown, incredibly rare natural phenomenon? Still unclear. We have no other examples. Or was it, as many secretly hoped, a genuine transmission from an extraterrestrial civilization? A beacon, a probe, or some other form of communication? We simply cannot know for sure without detecting it again. Adding to the strangeness, the Big Ear telescope was equipped with 2 detectors, which scanned the sky with a slight deliberate delay between them. The signal was uniquely observed in only one of these detectors, never in the second. This suggests that the source either abruptly turned off or moved out of the telescope's narrow field of view during the few minutes it took for the second detector to reach that specific point in the sky. The WOW signal remains a truly unique anomaly, arguably the strongest, most compelling candidate for an artificial extraterrestrial signal ever detected, but it is, tantalizingly, still unconfirmed, a cosmic whisper that faded into an enduring silence. From a single, elusive signal, let us now turn to a permanent resident of our own solar system, a world that also arrived here in a rather extraordinary, unexpected way. We're talking about Triton, Neptune's largest moon. Triton possesses one profoundly key feature that unequivocally betrays its immigrant origin. It orbits Neptune in a retrograde direction. That is to say, it moves in a direction precisely opposite to Neptune's own rotation, and, crucially, opposite to the orbital direction of almost all other large moons in the solar system. Nearly all large moons, those that form from the same swirling disk of gas and dust as their parent planet, naturally inherit that common direction of rotation. Triton's retrograde orbit, therefore, is an almost 100% definitive sign that it did not form natively near Neptune. Instead, it was once an independent object, very likely originating from the distant Kuiper Belt, a realm inhabited by worlds like Pluto or Eris. This rogue body, on its long journey, ventured too close to the colossal gravity of Neptune and was subsequently captured into orbit. Imagine this, a cosmic billiards game played out on an unimaginable scale. Neptune, with its immense mass, gravitationally caught the passing Triton, compelling it to remain in orbit around itself. Over vast eons, Triton's initial highly eccentric orbit was gradually reshaped by tidal forces, becoming almost perfectly circular. But its retrograde nature remained, an indelible scar, a profound piece of evidence of a turbulent, violent past. The capture theory also elegantly explains many of Triton's other fascinating peculiarities. Its surface is primarily covered with relatively young ices, frozen nitrogen, methane, and carbon monoxide, a telltale sign of recent, on geological timescales, geological activity. The Voyager 2 spacecraft, during its historic flyby in 1989, experienced active cryovolcanoes, or geysers, on Triton, erupting towering plumes of dark nitrogen gas and dust, reaching incredible heights of up to 8 kilometers. This astonishing activity is most likely fueled by intense tidal heating. Neptune's immense gravity constantly deforms and flexes Triton, much like squeezing a rubber ball, causing immense internal friction and generating sufficient heat to keep its interior active. These very same tidal forces, however, also have profound long-term consequences. They are gradually, inexorably slowing Triton's orbital motion. This means its orbit is slowly but surely decaying. It is spiraling ever closer to Neptune. According to precise calculations, in several 100 million or perhaps 1 billion years, Triton will inevitably cross Neptune's Roche limit. This is the theoretical boundary within which a planet's tidal forces become so overwhelming that they overcome the smaller moon's own self-gravity, the force holding it together. And then, Triton will be catastrophically torn apart, its icy debris scattering to form a new, possibly very spectacular ring system around Neptune. So this captured world, this cosmic immigrant, has its own preordained expiration date, a dramatic, inevitable end awaiting it in the distant future. Reflections on Triton's ultimate fate inevitably lead our thoughts to the grander, more profound fate of the entire universe. If the Big Bang marked the beginning, then what ultimately will be the end? One of the most probable hypotheses, based on our current observational data and theoretical understanding, is the heat death of the universe, also starkly known as the Big Freeze. This chilling concept is rooted in the second law of thermodynamics, which fundamentally states that in any closed system, entropy, a measure of disorder or the uniform distribution of energy, can only increase or, at best, remain constant over time. The universe as a whole, therefore, inexorably tends towards a state of maximum entropy, a condition of complete thermodynamic equilibrium. In the heat death scenario, the universe continues its relentless expansion forever. And, critically, as our observations now conclusively show, this expansion is accelerating, driven by the mysterious dark energy. What then transpires over unimaginably vast timescales, trillions upon trillions of years into the cosmic future? All processes, without exception, will gradually cease. Stars, having exhausted their nuclear fuel, will die out, transforming into cold, inert remnants, white dwarfs, neutron stars, and black holes. The remaining white dwarfs will eventually cool down to become theoretical black dwarfs, though the time required for this is far, far longer than the current age of the universe itself. Galaxies, propelled by the accelerating expansion, will fly so far apart from each other that they will become utterly imperceptible to any hypothetical observers in other galaxies, isolated in their own expanding cosmic bubbles. Even protons, the seemingly stable building blocks of atomic nuclei, may, according to some grand unified theories, prove to be unstable and eventually decay, though their estimated lifetime is an astronomical 10 to the 34th power years, or even longer. Ultimately, even black holes themselves, those ultimate gravitational traps, will, according to the groundbreaking theory of Stephen Hawking, slowly evaporate through a process known as Hawking radiation. This too will take an absurdly incomprehensibly long time. For a black hole with the mass of our Sun, an astounding 10 to the 67th power years. For supermassive black holes at the centres of galaxies, even longer still. When all matter has finally decayed or been irrevocably absorbed by black holes, and those black holes in turn have evaporated away, what will remain? Only an infinitely expanding, incredibly cold, a few degrees above absolute zero, dark, and almost utterly empty universe, sparsely filled with only the occasional photon, neutrino, and perhaps some leptons. In this ultimate state of thermodynamic equilibrium, there will be no temperature or energy differentials whatsoever, none of the gradients necessary for any work, any process, any change to occur. No new star formation, no chemistry, no life, no complex structures of any kind. The universe will have reached its maximum entropy, an eternal, uniform cold and darkness. This is a rather grim, yet based on our most current data, the most likely finale awaiting our universe. While scientists calmly speculate about the heat death occurring trillions of years from now, some people prefer to worry about much closer and often completely unscientific apocalypses. And this is precisely where Nibiru enters the scene, a name that has fueled countless doomsday prophecies. This term gained widespread popularity thanks to the books of Zecharia Sitchin, commencing with his provocative The 12th Planet, published in 1976. Sitchin, relying on his highly unconventional and scientifically unrecognized interpretations of ancient Sumerian texts, asserted that the Sumerians possessed knowledge of an additional, unknown planet in our solar system, which he called Nibiru. According to his sensationalized version, this planet has an extraordinarily elongated elliptical orbit and periodically passes through the inner solar system every 3,600 years. Furthermore, Sitchin boldly claimed that Nibiru is inhabited by a highly developed, technologically advanced civilization known as the Anunnaki, who, he alleged, visited Earth in the distant past, created humanity, primarily to mine gold for them, and were subsequently mistaken for divine beings. It is critically important to emphasize, however, that neither archaeologists nor linguists nor historians specializing in Sumerian culture lend any support whatsoever to Sitchin's interpretations. His translations and conclusions are universally regarded as pseudoscientific. There are no genuine Sumerian texts that describe Nibiru as a planet inhabited by the Anunnaki in the manner Sitchin describes. In actual Babylonian astronomy, the term Nibiru was likely associated with the planet Jupiter or the North Star, used to denote the point of an equinox or the crossing of the ecliptic. Sitchin's exotic ideas were, predictably, eagerly embraced by various esoteric groups, conspiracy theorists, and doomsday prophets. Nibiru was frequently identified with the hypothetical Planet X, a different, older concept, and its imminent return was repeatedly predicted, prophesying global cataclysms, pole shifts, devastating earthquakes, massive floods, or even a direct planet-destroying collision with Earth. These ideas gained particular fervent popularity in the run-up to the year 2012, when they were erroneously linked to the supposed end of the Mayan calendar cycle. As we all know, December the 21st, 2012, passed without any catastrophes related to Nibiru whatsoever. Astronomers state unequivocally, no planet Nibiru exists. If a massive planet with a colossal orbital period of 3,600 years were truly approaching Earth, its immense gravitational influence on the orbits of other known planets would have been undeniably noticeable long before its physical appearance, and the planet itself would have been clearly perceivable in telescopes years prior to any close approach. Modern sky surveys, meticulously scanning for dim objects on the very outskirts of the solar system, including the legitimate search for the actual scientific planet 9, have found absolutely nothing resembling Sitchin's Nibiru. It is pure fiction, entirely lacking any scientific basis. It is crucial, therefore, to distinguish the pseudoscientific Nibiru from the entirely scientific hypothesis about Planet 9. Unlike the mythical Nibiru, a very real, tangible message was deliberately sent from Earth, harnessing the immense power of one of the world's most formidable radio telescopes. This is the Arecibo message. On November the 16th, 1974, using the colossal 305-meter radio telescope in Arecibo, Puerto Rico, the same iconic instrument that tragically suffered a catastrophic collapse in 2020, a carefully crafted radio message was beamed towards the globular star cluster M13, located in the constellation Hercules. This particular star cluster is situated approximately 25,000 light-years from Earth and contains hundreds of thousands of densely packed stars. It was chosen specifically to maximize the chances that some hypothetical recipient civilization might be positioned within the signal's narrow path. The message itself was remarkably concise, lasting only 169 seconds, and consisted of a precise sequence of 1,679 binary pulses, simply ones and zeros. The number 1,679 was chosen with profound deliberation. It is the product of two prime numbers, 23 and 73. This, in itself, was a clever clue embedded for the potential recipients. If the bits are arranged into a rectangular grid of 23 rows by 73 columns, or vice versa, an image, a pictogram, should emerge. When correctly decoded, 73 rows by 23 bits to be exact, a clear, structured pictogram indeed appears, containing basic, fundamental information about humanity and our home planet. From top to bottom, the image depicts the numbers from 1 to 10 in binary code, the atomic numbers of the main elements essential for life: hydrogen, carbon, nitrogen, oxygen, and phosphorus, the chemical formulas for the sugars and bases that constitute DNA nucleotides, a schematic representation of the iconic DNA double helix structure, along with the approximate number of nucleotide pairs in the human genome, a stylized figure of a human being with an indication of average height and the Earth's population as of 1974, a diagram of our solar system with Earth clearly highlighted, and finally an image of the Arecibo telescope itself with its impressive diameter indicated. The brilliant minds behind this transmission were none other than Frank Drake, him again, and Carl Sagan. It is vital to understand that this message was conceived more as a profound symbolic demonstration of our technological capabilities than a genuine immediate attempt to establish contact. After all, M13 is so incredibly distant that light, and thus the radio signal, will take a staggering 25,000 years to reach it. Even if a civilization exists there, receives the signal, manages to understand it, and immediately sends a reply, we would not receive that response for at least 50,000 years. Moreover, during this immense span of time, the M13 cluster itself will have significantly shifted its position due to the galaxy's rotation, and the signal will likely miss its ultimate destination. But as a potent symbol, as the very first targeted and complex radio message ever broadcast to the stars, the Arecibo message remains an indelible, important milestone in the ongoing history of SETI. The Arecibo signal was purposefully beamed from Earth. But to truly study the earliest, most fundamental signals of the universe itself, space observatories, unhindered by Earth's obscuring atmosphere, were absolutely essential. One of the earliest, and without doubt most profoundly important, was COBE, the Cosmic Background Explorer. This pioneering NASA satellite was launched in 1989 with the specific, ambitious goal of meticulously studying that very cosmic microwave background radiation, the faint, omnipresent echo of the Big Bang. And COBE, in its remarkable mission, made two fundamental discoveries that irrevocably revolutionized cosmology, ultimately earning its scientific leaders, John Mather and George Smoot, the coveted Nobel Prize in Physics in 2006. First, the FIRAS instrument aboard COBE measured the spectrum of the CMB with unparalleled precision and confirmed, with astonishing accuracy, that it perfectly matched the theoretical spectrum of a black body with a temperature of 2.725 Kelvin. This was the most powerful, definitive confirmation of the hot Big Bang theory. The universe truly was once in a state of dense, fiery thermal equilibrium. Second, another instrument, the DMR, reliably detected for the very first time the anisotropy of the CMB, those incredibly tiny temperature fluctuations, differences on the minuscule order of 1/100,000th of a degree in different directions across the sky. Prior to COBE, these fluctuations were only predicted by theory but had not been confidently experienced. It was precisely these inhomogeneities, this subtle ripple in the early universe, that became the gravitational seeds from which all the large-scale structures we perceive today, galaxies, vast clusters of galaxies, subsequently grew under the relentless influence of gravity. Had the early universe been perfectly, utterly uniform, then today it would simply be filled uniformly with gas, devoid of stars, galaxies, and planets. COBE's groundbreaking discoveries transformed cosmology from a realm of theoretical speculation into a precise, observational science, laying the indispensable foundation for subsequent, even more precise missions like WMAP and Planck. COBE showed us how gravity acted at the very dawn of time, assembling matter from primordial fluctuations. But gravity is a force that not only assembles, it can also profoundly distort the path of light, acting like a colossal cosmic lens. This astonishing phenomenon is called gravitational lensing. It was first predicted by Albert Einstein's revolutionary general theory of relativity, which posits that mass, and indeed energy, profoundly warps the very fabric of space-time around it. When light emanating from a distant object, such as a remote galaxy or an energetic quasar, passes near a massive object in the foreground, perhaps another galaxy, a colossal cluster of galaxies, or even an enigmatic black hole, its path is bent, refracted by this immense gravitational field. As a result, we, as observers, can experience distorted, magnified, and sometimes even multiple images of the distant source. It is fundamentally similar to how an ordinary glass lens refracts and focuses light. Gravitational lensing has, in a relatively short time, become an incredibly powerful and indispensable tool for astronomers. Firstly, it allows us to discern and study objects that would otherwise be far too faint or too distant to perceive directly. The gravitational lens can amplify the light from the background object by tens of times, effectively acting as a natural cosmic telescope. This is precisely how some of the most distant known galaxies in the universe have been discovered. Secondly, and perhaps even more profoundly, lensing provides our primary indirect means to feel and meticulously map the distribution of invisible dark matter. Dark matter, by its very nature, does not emit, absorb, or reflect light, rendering it undetectable by conventional means. However, it unequivocally possesses mass and therefore exerts gravity, and consequently it too bends light. By painstakingly studying how the images of background galaxies are distorted as their light traverses a galaxy cluster, astronomers can construct a detailed map of the total mass distribution within that cluster, crucially including the dark matter, which constitutes the bulk of its mass. The most spectacular manifestations of this phenomenon are strong lensing events, where the light from a distant source is contorted into brilliant arcs or even complete luminous circles famously known as Einstein rings, which form when the source, the lensing object, and the observer are perfectly aligned in a cosmic ballet. Gravitational lensing not only provides stunning confirmation of Einstein's theory, but also grants us a unique, unparalleled tool to explore the farthest, darkest corners of the universe and probe its elusive dark side. Gravity helps us uncover the invisible, but the profound question of invisible, as yet undiscovered life in the universe remains wide open, giving rise to one of the most famous and unsettling paradoxes, the Fermi paradox. It is named after the brilliant enigmatic physicist Enrico Fermi, who, according to a now legendary account, posed a deceptively simple question to his colleagues during a casual lunch at Los Alamos in 1950. So where is everybody? The essence of this paradox lies in the stark contradiction between the high theoretical probability of the widespread existence of extraterrestrial civilizations and the complete, frustrating lack of any observable evidence of their existence or any contact with them. On the one hand, our own Milky Way galaxy alone contains hundreds of billions of stars. Many, if not most, of these stars are likely to host planetary systems. A significant fraction of these planets might well reside in the habitable zone, that specific orbital region where conditions could allow for the existence of stable liquid water on a planet's surface. Given the immense age of the universe, nearly 14 billion years, life has had ample, perhaps even redundant time to arise and evolve into intelligent, technologically advanced civilizations on countless planets. The visionary astronomer Frank Drake even proposed an equation in 1961 to estimate the number of such civilizations in our galaxy, capable of engaging in interstellar communication. Although the values of many parameters within the Drake equation are still highly uncertain, even by the most conservative, cautious estimates, there should theoretically be quite a few such civilizations thriving out there. But on the other hand, the profound silence. We observe no clear, unambiguous signs of their activities, no consistent, decipherable radio signals, except for tantalizing, unrepeated mysteries like the "wow" signal. No colossal astro-engineering structures such as Dyson spheres, hypothetically designed to harness a star's energy, like those once speculated around Tabby's star. No probes, no ships, no discernible cosmic fingerprints. Decades of dedicated SETI, search for extraterrestrial intelligence searches, have so far yielded absolutely nothing but silence. So, where indeed is everyone? Numerous, often unsettling explanations for the Fermi paradox have been proposed, which can generally be grouped into several categories. Perhaps they simply don't exist. The rare Earth hypothesis suggests that the emergence of life, particularly complex and intelligent life, requires an extraordinarily unique confluence of many extremely improbable circumstances, a chain of felicitous accidents that perhaps occurred only once, here on Earth. Alternatively, perhaps they exist, but we simply don't perceive or hear them. Space, after all, is truly vast, immeasurable. Interstellar travel and communication might be incredibly difficult, prohibitively expensive, and excruciatingly slow, making detection improbable. Maybe they employ technologies or modes of communication that we, with our current understanding, simply cannot detect or even comprehend. Not radio, but something entirely different. Perhaps they are so fundamentally different from us that we fail to recognize them as life or intelligence. Or, more unsettlingly, maybe they deliberately hide, adhering to a strict policy of non-interference, the so-called zoo hypothesis, observing us from afar like specimens in a cosmic preserve. Finally, a chilling possibility. Perhaps they existed, but have vanished. The Great Filter hypothesis suggests that there is some insurmountable barrier, a filter, along the path of a civilization's development that almost none can overcome. This filter could lie behind us, meaning the origin of life or intelligence is an exceedingly rare event that we, by sheer luck, have already passed. Or, and this is the truly chilling part, it could still lie ahead of us. This means that civilizations, once they reach a certain technological level, inevitably self-destruct through mechanisms such as catastrophic wars, irreversible ecological collapses, uncontrolled artificial intelligence, devastating pandemics, or are obliterated by natural cosmic cataclysms like lethal gamma-ray bursts. This latter possibility, if true, carries profound implications for our own future. The Fermi paradox ultimately is not merely a scientific problem demanding a clear-cut solution. It is a profound philosophical question that compels us to reflect deeply on our unique place in the universe and indeed on the very future of humanity itself. The Fermi paradox forces us to question our deepest assumptions about the cosmos. But sometimes, people manage to doubt even the most basic, fundamentally established things. For example, the undisputed fact that the Earth revolves around the Sun. Yes, claims that this is not the case are, astonishingly, still encountered today. Let's settle this, once and for all. This is a profound misconception rooted in ignorance or a fundamental misunderstanding of the basic principles of astronomy and physics. Modern science has unequivocally and definitively established that the Earth revolves around the Sun. This model, known as heliocentric, meaning sun-centered, was first rigorously proposed by the brilliant Polish astronomer Nicholas Copernicus in his seminal book On the Revolutions of the Heavenly Spheres, published in the year of his death, 1543. Copernicus's ideas were nothing short of revolutionary, as for almost 1,500 years prior, the geocentric model of Ptolemy had dominated thought, a model in which the Earth rested motionless at the very centre of the universe, while the Sun, Moon, and all other planets supposedly revolved around it. Why then is heliocentrism correct? It has been overwhelmingly confirmed by a multitude of independent observations and groundbreaking discoveries. Galileo Galilei, using his revolutionary telescope, experienced the phases of Venus, which are only possible if Venus revolves around the Sun, not the Earth. He also discovered the moons of Jupiter, irrefutably proving that not everything in the cosmos revolves around the Earth. Johannes Kepler meticulously derived the laws of planetary motion, precisely demonstrating that planets move in elliptical orbits around the Sun, and Isaac Newton, with his universal law of gravitation, provided the ultimate physical reason for this motion. The Sun, with its immense mass, exerts a gravitational attraction on the Earth, while the Earth's orbital velocity, its inertia, prevents it from falling directly into the Sun, keeping it in a stable, predictable orbit. Technically, both the Earth and the Sun revolve around their common centre of mass, known as the barycenter. However, since the Sun is an astonishing 333,000 times more massive than the Earth, this barycenter is located deep within the Sun's interior. Therefore, for simplicity, we accurately state that the Earth revolves around the Sun. Why then does anyone still cling to the geocentric idea? Perhaps it is an echo of the old geocentric model, which, after all, seems intuitively understandable. We don't feel the Earth's rapid motion, or it is simply a profound lack of scientific education. But from a rigorous scientific point of view, the question has been settled for centuries. Earth is the third planet from the Sun, and orbits it in a near-elliptical path approximately every 365.25 days. While we're sorting out Earth's familiar orbit, there are objects in the distant frigid reaches of the solar system with far more peculiar characteristics. For example, the fascinating dwarf planet Haumea. It resides in the vast icy expanse of the Kuiper Belt, far beyond Neptune's orbit. Its discovery was announced in 2004, sparking disputes over priority between American and Spanish groups of astronomers, and in 2008 it officially received the status of a dwarf planet. But what makes it so uniquely interesting? Firstly, its shape. Haumea is not a sphere at all. It possesses the highly unusual elongated form of an ellipsoid, strikingly resembling a rugby ball or a flattened cantaloupe. Its length along its longest axis stretches to about 2,300 kilometers, while along its shortest axis it measures less than 1,000 kilometers. Secondly, and critically, the reason for this bizarre shape is its incredibly rapid rotation. Haumea completes a full rotation on its axis in an astonishingly brief 3.9 hours. This makes it one of the fastest rotating large objects, defined as those with a diameter over 100 kilometers in the entire solar system. It is this furious rotational speed that has physically stretched it into its elongated form due to immense centrifugal forces. Thirdly, Haumea is not alone. It possesses two small satellites, charmingly named after the daughters of the Hawaiian goddess Haumea, Hiaka and Namaka. Fourthly, in 2017, astronomers made another groundbreaking discovery: a ring system encircling Oumuamua. This marked the very first detection of rings around an object in the Kuiper Belt, a truly unexpected finding. Oumuamua's surface is predominantly covered with highly reflective water ice and is remarkably bright. How did such a strange, dynamically unique world come to be? The most plausible scenario points to a colossal, large-scale collision in its distant past. Oumuamua likely collided with another substantial Kuiper Belt object. This cataclysmic impact not only spun it up to its enormous rotational speed and gave it its elongated shape, but the material violently ejected during the collision subsequently condensed into its two moons and the newly discovered ring. There is even an entire Oumuamua family of objects, a distinct group of small, icy bodies in the Kuiper Belt that share similar orbits and surface compositions, believed to be fragments from that ancient planet-shattering collision. Oumuamua stands as a vivid, compelling example of just how dynamically active and profoundly strange worlds can be, even in the cold, distant backwaters of our solar system. Oumuamua's rapid rotation is a violent legacy of a colossal collision. But our neighbouring planet, Venus, rotates, conversely, with astonishing slowness, and even more bizarrely in the opposite direction. For this reason, it is often aptly dubbed the ups and down planet. Almost all other planets in the solar system rotate on their axis in the same direction they orbit the Sun, counterclockwise when viewed from the Sun's North Pole. But Venus rotates clockwise. This is known as retrograde rotation. If you were somehow standing on the hellish surface of Venus, the Sun would rise in the west and set in the east. Not only that, but its rotation is excruciatingly slow. One complete rotation on its axis, a sidereal day, takes a staggering 243 Earth days. Meanwhile, a year on Venus, one orbit around the Sun, lasts a mere 225 Earth days. This means, astonishingly, that a single day on Venus is longer than its entire year. Venus's axis of rotation is almost perfectly vertical, with an incredibly small tilt of only about 3 degrees, in stark contrast to Earth's 23.5 degrees. Consequently, Venus experiences no distinct seasons, unlike our home planet. Why then does Venus rotate so strangely, so slowly, and in reverse? There is no definitive, universally accepted answer. Instead, two main hypotheses dominate scientific discussion. The first posits a giant impact early in its history, a catastrophic collision that could have dramatically slowed its initial rotation and even completely flipped its axis. The second, currently more widely favoured, suggests a complex interplay of the Sun's immense tidal forces with Venus's incredibly massive dense atmosphere and its planetary interior, specifically the friction between its mantle and core. These intricate effects could have gradually, over billions of years, braked Venus's initial, possibly fast and direct rotation, leading to its current slow and retrograde state. Whatever the ultimate reason, this unique, profoundly peculiar rotation, combined with its crushing carbon dioxide atmosphere and a surface temperature so hellish it melts lead, around 465 degrees Celsius, makes Venus one of the most mysterious, inhospitable, and utterly extreme worlds in our solar system. We have already touched upon the collision hypothesis, invoked to explain how Venus or Uranus might have been flipped, or how Oumuamua acquired its bizarre shape. But what if a catastrophic collision or disruption occurs not to a planet itself, but to one of its moons? There is a highly plausible and increasingly favoured hypothesis that elegantly explains the origin of Saturn's magnificent rings precisely by the destruction of one of its moons, or perhaps a cluster of several smaller moons, or even a large passing comet. Saturn's rings, as we know, are an astonishing spectacle, composed of countless individual particles ranging in size from microscopic dust specks to house-sized boulders. They are predominantly made of pure water ice, with only trace amounts of rocky material. These rings stretch for hundreds of thousands of kilometers across the sky, yet they are surprisingly, impossibly thin. The thickness of the main rings is a mere few tens of meters. The Roche limit plays a crucial role here. This is a theoretical boundary around any massive body, such as a planet, within which the tidal forces exerted by that planet become so immensely strong that they overcome the self-gravity of a smaller body, a moon or an asteroid, that is attempting to hold itself together. If a moon, especially one composed mainly of ice, for some reason, perhaps due to complex gravitational perturbations from other moons, ventures too close to Saturn and crosses this critical Roche limit, it will be catastrophically torn apart by those overwhelming tidal forces. The resulting fragments would then spread out along the moon's original orbit, gradually forming a ring system. The disrupted moon hypothesis excellently explains the observed composition of the rings, predominantly water ice. Furthermore, data meticulously collected by the Cassini mission, which devoted many years to studying Saturn and its system, strongly indicate that the rings might be surprisingly young on astronomical timescales. Their age is estimated to be perhaps only 10 to 100 million years old, a mere blink of an eye compared to Saturn's own age of 4.5 billion years. If the rings are indeed that astronomically young, then the scenario of their formation resulting from the relatively recent, again, in cosmic terms, destruction of one or more icy moons becomes profoundly attractive. Of course, other possibilities exist. Perhaps the rings formed from leftover material that failed to coalesce into a moon during Saturn's primordial formation, or from the debris of collisions between existing moons. However, the hypothesis of a tidally disrupted moon currently appears the most convincing, particularly given the strong evidence for the rings' relative youth. Pondering the dramatic destruction of moons and the ultimate future of the universe, one cannot fail to mention another hypothetical cosmic fate, one that stands in stark opposition to the heat death, the Big Crunch theory. If the heat death describes an eternal expansion and cooling, then the Big Crunch envisions a scenario in which the relentless expansion of the universe eventually reverses, giving way to a period of contraction. Imagine playing a film of the Big Bang in reverse. According to this hypothesis, if the average density of matter and energy in the universe was sufficiently high, their mutual gravitational attraction could, over vast eons, eventually overcome the forces of expansion, including the mysterious dark energy, if its properties were to change over time. In this case, the expansion of the universe would inexorably slow down, grind to a halt, and then the reverse process would commence: contraction. Galaxies would begin to hurtle towards each other, merging and colliding with increasing frequency. The temperature and density of the universe would rapidly, catastrophically increase. Stars and planets would be destroyed in the intensifying inferno. Ultimately, all matter and energy would collapse back into a super-dense and super-hot state. A singularity perhaps terrifyingly similar to the one from which the Big Bang is believed to have originated. For such a scenario to occur, the universe must possess a specific geometry. It must be closed, with positive curvature, like the surface of a sphere, and/or contain enough mass energy for gravity to ultimately dominate. However, as we already know, modern observations overwhelmingly suggest the opposite. In the late 1990s, the astonishing accelerated expansion of the universe was discovered, a revelation for which the Nobel Prize was awarded in 2011. This means that some mysterious force, dark energy, is actively pushing the universe apart faster and faster, and gravity, it seems, is unequivocally losing this cosmic battle. The observed density of the universe also appears insufficient to halt the expansion, let alone reverse it. Therefore, the Big Crunch scenario, at least in its simplest form, is currently considered highly unlikely by the vast majority of cosmologists. Most now lean strongly towards the probability of eternal expansion and the chilling heat death. Although, of course, the fundamental nature of dark energy remains largely unexplained, and who knows if its behavior might subtly, or even dramatically, change in the unimaginably distant future. Sometimes the Big Crunch is considered as part of cyclical models of the universe, where a contraction is followed by a new bounce and a new Big Bang, but that is a completely different, even more speculative story. To truly understand whether a crunch or a freeze awaits us, we desperately need to measure the fundamental parameters of the universe with exquisite accuracy: its age, its composition, its expansion rate, and its overall geometry. And a monumental contribution to this endeavour was made by the NASA spacecraft Oumuamua. the Wilkinson Microwave Anisotropy Probe. Launched in 2001 as the highly anticipated successor to COBE, WMAP was specifically designed to create an even more detailed, higher resolution map of the cosmic microwave background, the faint, omnipresent echo of the Big Bang. And it succeeded brilliantly in this formidable task, transforming cosmology into a science of unparalleled precision. Map data allowed us to refine the age of the universe with remarkable accuracy, approximately 13.77 billion years. The even more precise modern estimate from the Planck mission is 13.8 billion years, an astonishingly close agreement. But perhaps most importantly, WMAP determined the precise composition of the universe with unprecedented accuracy. It revealed that the ordinary baryonic matter we are familiar with, the stuff of stars, planets, and ourselves, constitutes a mere 4.6% of the total mass-energy budget. Another 24% is attributed to the mysterious dark matter, which does not interact with light, but undeniably participates in gravity. And the vast, overwhelming majority, an astonishing 71.4%, is the even more enigmatic dark energy, the force responsible for the universe's accelerated expansion. These figures, later slightly refined by the Planck mission, were nothing short of shocking. We are made of the rarest type of substance in the entire universe. WMAP also conclusively confirmed that the overall geometry of the universe is remarkably close to being perfectly flat or Euclidean. This flatness is a powerful argument in favour of the theory of cosmic inflation, the ultra-rapid expansion in the earliest moments of the universe. The meticulously detailed map of CMB temperature fluctuations created by WMAP quickly became an iconic image of modern science, truly the baby picture of our universe, allowing us to rigorously test and refine models of its dramatic birth and subsequent evolution. MAP thus laid the indispensable foundation for the so-called Standard Cosmological Model, or Lambda CDM, which describes a universe composed mainly of dark energy, lambda, and cold dark matter, and which, despite remaining profound mysteries, stands as the universally accepted standard today. Refining the universe's composition with WMAP and acknowledging the existence of dark matter and dark energy is one thing, but sometimes amusing and even heated stories arise with the classification of visible objects within our own solar system. Remember the great fuss about the 10th planet? This particular story dramatically unfolded in the mid-2000s. Astronomers, spearheaded by the indefatigable Mike Brown from Caltech, were diligently and successfully discovering new large objects in the distant Kuiper Belt. And in January 2005, they triumphantly announced the discovery of an object that they named Eris. Preliminary estimates, based on its brightness and presumed reflectivity, indicated that Eris was more massive than Pluto. This presented the entire astronomical community with a profound, urgent dilemma. If Pluto, the long-reigning 9th planet, was indeed a planet, shouldn't Eris, which was larger, also be considered the 10th? And what about other substantial objects like Haumea or Makemake, which were also being discovered around the same tumultuous time? Where precisely should the arbitrary line between planet and not planet be drawn? The ensuing debates were heated, passionate, and often deeply personal. Ultimately, the International Astronomical Union, or IAU, at its General Assembly in August 2006, for the very first time in history, formally defined the precise criteria for the term planet. According to this new, rigorous definition, to be considered a planet, a celestial body must fulfill 3 crucial conditions. 1. It must orbit the Sun. 2. It must have sufficient mass for its own self-gravity to overcome the rigid body forces, allowing it to assume a hydrostatic equilibrium, meaning a nearly round, spherical shape. And 3. It must have cleared the neighbourhood around its orbit, meaning it must be the gravitationally dominant object in its orbital zone, not sharing it with other bodies of comparable size, with the notable exception of its own satellites. Pluto, it became clear, like Eris and other Kuiper Belt objects, definitively failed to satisfy this 3rd critical criterion. It shares its orbital zone with numerous other icy bodies of significant size. Therefore, the IAU made the momentous decision to reclassify Pluto, assigning it the status of a new class of object, the dwarf planet. Eris, Haumea, Makemake, and Ceres, the largest object in the main asteroid belt located between Mars and Jupiter, also subsequently fell into this newly defined class. Thus, no 10th planet emerged, and the number of official planets in the solar system was definitively reduced to 8. Although the term 10th planet still occasionally surfaces in the media, sometimes mistakenly applied to the entirely hypothetical Planet 9, officially Eris is now, and forever will be, a dwarf planet. This fascinating story serves as an excellent example of how scientific classification itself evolves and adapts as new data accumulates and our understanding of the cosmos deepens. As the chaos of the cosmos continues its relentless march, remember the sheer luck of this fragile, ordered moment. May you feel the awe of your own unlikely consciousness tonight,